In this lesson, we're going to be working with two general probability formulas, and we're also going to talk about two types of relationships that we can have between events. The special relationships that we're going to be talking about are independent events and mutually exclusive events. And it's important to know and understand these concepts because that's going to help us determine the way we use our formulas when we calculate our probabilities. So first, let's take a look at the two general probability formulas. So we have what's called the addition rule, and that's when we have two events, and we're trying to find the probability of A or B. And if you recall, just as a quick review, the OR symbol looks like a U, so it could be stated with that instead. So to find the probability of A or B, you take the probability of each of those separately and add them, and then you subtract off anything that they have in common, the probability of A and B. That's going to be our overlap. Now, the multiplication rule, that is used when we're trying to find a probability of an AND statement. The probability of an event A and B is equal to the probability of A times, and then we have our conditional probability, times the probability of B given A. So this is when we assume that event A has occurred. So to find the probability, we find the probability of A times the probability of B given that A has happened, or that the assumption is true. It can also be written with the letter swapped. You don't have to always write it with the A first. It just depends on what labels you're using with your question. But you can also use this formula where you swap the letters. So just be aware of that. And a quick refresher, the AND symbol is the upside down U. So it could be shown using that symbol as well. All right, now let's look at our special relationships more closely. We're going to talk about independent events and mutually exclusive events. Independent events are situations where one event doesn't influence the other. So think about an event where you're flipping a coin and an event where you're rolling a die. And you're doing that back to back. So you flip a coin and then you roll a die. The result that you get when you roll the die is not affected by what happens when you toss the coin. Those two events, rolling a die and flipping a coin, are not going to affect each other. So that is what you consider conceptually as an independent event. Now, if you want to see what it looks like mathematically, if two events are not going to affect each other, then the conditional probability is going to be the same as the standalone probability. So if I have the probability of B given the assumption that event A has happened, because they're independent, it doesn't matter if event A has happened or not, these two probabilities are going to be the same. And it works if we switch the letters as well. If A and B are independent, it doesn't matter if we make the assumption that B is true, the probability of A is going to be the same no matter what. So because of that, if we look at our general multiplication rule, we have the probability of A and B is equal to the probability of A times the probability of B given A has happened. If two events are independent, then we know that this is equivalent to the probability of B because it does not matter if A has happened or not because the probability of B is not affected. So when two events are independent, you can just write the formula by taking the probability of A times the probability of B, and you don't need to worry about that conditional. But that only works in the special case that you know that A and B are independent. Now, on the other hand, if you're looking at mutually exclusive events, that means that they cannot happen at the same time and there's going to be no overlap. So if we look at the diagram, if we look at two events, A and B, they don't have anything in common. Those two sets have nothing in common. There's no overlap. So when I look at the probability of both of them happening at the same time, that's going to be 0. So when I know two events are mutually exclusive, I also know automatically that the probability of A and B is going to be 0. So that's written here. When you have events that are not mutually exclusive, that means there is overlap. So they have something in common, which means when you find the probability of both A and B happening together, it's going to be something other than 0. Now, when we look at the general formula for addition, we have the probability of A or B is equal to the probability of A plus the probability of B, and then we subtract off that overlap, the probability of A and B. That way we're not double counting anything. When we have events that are mutually exclusive, I know that the probability of A and B is equal to 0. So I don't need to worry about subtracting that overlap, which is why when two events are mutually exclusive, to find the probability of A or B, we only need to add the two probabilities together. Let's look at example 1. Suppose the probability of A is equal to 0.45 and the probability of B given A is 0.60. Find the probability of A and B. So to find the probability of A and B, using our multiplication rule, we have the probability of A times the probability of B given A, or the other way that we can write it, we can flip-flop the letters. Where we could have the probability of B times the probability of A given B has happened. Now, there are times one way you'll be able to use, I might be able to use this one, or another time I might be able to use this one, the second one. But it just depends on the information that's given to you. In this question, we're given the probability of A and the probability of B given A has happened. So that means we're going to use this formula right here that I underlined in green, because that is the information that we have to figure out the probability of A and B. The probability of A is 0.45. So I'm going to substitute that in for the probability of A. And I'm going to multiply that by the probability of B given A, which is 0.60. And when I do that, I'm going to get 0.27. So the probability of event A and B is equal to 0.27. Let's look at example 2. Suppose that the probability of A is 0.38, the probability of B is 0.44, and the probability of A and B is 0.19. We need to find the probability of A or B. So we're going to use our addition rule for this. The probability of A or B is equal to the probability of A plus the probability of B, and we subtract what they have in common so we don't double count anything. In this case, I'm going to substitute the probability of A, and I'm going to put in its place 0.38 because that's what the probability of A is equivalent to. I'm going to replace the probability of B with 0.44. And then I'm going to subtract the probability of A and B, which is 0.19. Now, when I work that out, I'm going to get that the probability of A or B is 0.63. That is the way you can look at it in terms of the formula. Now, let's look at it in terms of a Venn diagram. Let's say I have event A in this circle. And let's say I have event B in this circle. In the previous lesson, we talked about when we create our Venn diagrams, we look at the center first, where all the overlapping is, and then we work out. So where it overlaps is 0.19, right? We got the probability of A and B is 0.19. So when I look at the probability of A as 0.38, I already have 0.19 in the circle for A. So I can only add in 0.19 so that the total in the circle is 0.38. So if I take 0.19 and 0.19 in the green circle, that gives me 0.38 for the probability of A. Now I got to do that same thing with B. When I look at B, the probability is 0.44. However, I already have 0.19 in the purple circle. So I don't want to add in 0.44 because that would give me 0.44 plus the 0.19. I want the total to be 0.44. So that means that I can only add in 0.25. So now when I want to find the probability of A or B and I don't double count, if I add up 0.19, 0.19, and 0.25 without double counting that 0.19, what I get is 0.63. So let me write that down. 0.19 plus 0.19 plus 0.25, that's going to give me 0.63. So looking at it with the Venn diagram, hopefully that helps you see how the formula works.